Welcome back to the channel, guys. Let us start with stack. Stack is a container that follows last in first out principle, which means the element that is inserted at the last is going to be removed at the first. So in stack there are multiple functions like push, pop, top, empty, size. Push function is used to add elements, pop function is used to remove elements, top function returns the element present at the top. Empty is used to check if it is empty, and size is used size gives us the size of the stack. Time complexity for all of the above functions is big of 1. And in stack there is no random access of elements as we used to access in map, set, and vector. Here we can only access the top element of the stack. Some of the common applications of stack are parenthesis matching for undo redo, function call stack, recursion, next greater element, previous greater or smaller element, expression evaluation, and monotonic stack problems. Now, coming to queue, it is a container that follows first in, first out principle, which means whichever element is coming first will be removed first. It also has similar functions like stack, like push, pop, front, back, empty, and size. The four functions are same. The only difference is these two. Front gives us the first element of the queue and back gives us the last element of the queue. Also here also time complexity for all of the above functions is big of 1. Now the main thing, priority queue. Priority queue is different from normal queue. In normal queue we remove element which come first by using the first in first out principle. But in priority queue, things work differently. In priority queue, we remove the element with the highest priority according to its ordering. So by default, largest element has priority in a priority queue because it is implemented in max heap. Now, what if we want the priority to be the smallest element? Like smallest element should have the highest priority. So for that, we declare the priority queue like this: int, vector int, and greater int. So this is the declaration when we want smallest element to pop first. Time complexity in priority queue are, for most of the functions, they are big of 1, but the two key functions, push and pop, have time complexity of O of log n because as it maintains heap, the length of heap is log n, so it will require big of log n for push and pop. Now, queue is used for BFS level order traversal scheduling, and priority queue is used for top k problems, kth largest problem, heap problems, Dijkstra, scheduling, and greedy algorithms. The Yeah. Now this is the one key thing I wanted to tell you guys, that there are some underlying data structures that are used behind the STLs that we use. So array, you know that array is stored in contiguous memories. Vector is stored in dynamic contiguous memories. Stack is implemented by DQ. Queue is also implemented by DQ. Priority queue uses heap. Set, multiset, map, and multimap. These all use balanced search trees. And unordered set and unordered map uses hash table. Now we'll look at the code. So coming to the code implementation, I've already written the code so it can save your time. Now here you can see that stack is declared st, and there are three values pushed in the stack. Sorry, pushed in the stack. Then st.top will give us the top of the stack. Again st.top because we are popping one. Here I can show you how it works, last in first out. Then here queue, I have declared a queue, pushed three values. Here also I have got front and back, and here I have popped the value. So the first value will get popped because first in first out, and I only showed front value because it is getting popped, so it will change. And coming to priority queue, we have declared a priority queue, we have inserted three elements. And here I'll just show you the top. Here we have inserted in a random manner, that is 10, 30, 20. So largest element has always largest priority by default, so top should be 30, and after popping 30 the top should become 20. So I'll just show you by running code. I'm so sorry guys, I just need to add line break for each of them so that you can understand the output. Just 1 minute. Okay, so now you can understand the output. Yeah, here you can see top of the stack is 30 because last inserted element is 30, and once we pop the last inserted element, so top of the stack becomes 20. Now coming to queue, the front of the queue is 10, which is inserted at the beginning, and back of the queue is 30, which is inserted at the, sorry, which is top front of the queue is 10 inserted at the first, and back of the queue is 30 inserted at the last. Now when we pop the value, it will pop the first value, that is 10, so front will become 20. This means you can see that it uses first in first out principle, and you have also seen that stack uses last in first out principle. Now we'll look at priority queue. Priority queue's top is 30 because it is the largest. So once we pop that, the top will become 20. Next largest, so it has higher priority. So this is how stack queue and priority queue works. I'll also try to show you the priority queue where smallest element has priority. So for that we'll just change, make some changes. And yeah, now you can see that the top of the priority queue should be 10, and after popping it should become 20. I'll just run the code once after clearing the terminal. Okay, here you can see top of priority queue is 10, so smallest element is the priority as we have changed the declaration, and after popping 10 it becomes 20. So that is it for this video. Now in next video we are going to see algorithms, which will be our last part of the STLs, and after that our STLs will be completed.